Hello, SAM students. Remember, the purpose of this video is to just check your answers, so you should try each problem before you watch the video. Number 1, Ms. Bierman's quiz grades are normally distributed with a mean of 76 and a standard deviation of 6. What percent of the scores are below 60? The first thing I'm going to do is calculate the z-score. The formula for z-score is x minus x bar over s. I recommend that you write this equation every single time you do a problem. X is the data value we're looking at, so x is 60. X bar stands for the mean, which is 76, and s is the standard deviation, which is 6. On my calculator, I got negative 2.666, and I rounded that to negative 2.67. On the z-score table, I found that that corresponded with a percent of 0.0038 or 0.38%. Since the z-score table gives us the percent that is below 60, to find the percent that is above 60, I simply subtract the percent that's below from 100, and I'll get the percent that's above. To find the percent that's above 90, I first find the percent that is below 90, and then I will subtract that from 100. In my calculator, I did 90 minus 76 divided by 6, and I got 2.33. My z-score table told me that 99.01% of the data are below 90, so 100 minus 99.01, or 0.99% of the data, are above 90. For part D, it's helpful to draw a diagram so I know which area I'm looking at. So I draw myself a normal curve with 76 in the middle. I want the percent that are between 80 and 90. So what I'll do is subtract the percent that are below 90 minus the percent that are below 80. The reason I do that is to cut off this tail, since we only want this area. I already know that 99.01% of the data are below 90. To find the percent that are below 80, I calculate the z-score, 80 minus 76 over 6, and I get 0.67, which corresponds to a percent of 74.86. When I subtract, I found that 24.15% of the data are between 80 and 90. Number 2 asks us to calculate the z-score and then find the percent that are less than 30. I start out with my formula, x minus x bar over s. Plug in 30 for x, 23 for x bar, and 4.1 for s, and I get a z-score of 1.71, which corresponds to a percent of 95.64. I did the same thing for part B, x minus x bar over s, so that would be 0.75 minus 1 divided by 0.2. I got a z-score of negative 1.25. On my chart, I found that negative 1.25 corresponded to a percent of 0.1056, or 10.56%. Part C, I did x minus x bar over s, 75 minus 68 over 8, and I got a z-score of 0.875. Make sure you remember that this is not a percent, this is the z-score. So on my z-score table, I looked up 0.875, and I found 0.8051, which is 80.51%. What does it mean for a set of data to be normally distributed? It means that most of the data are clustered around the mean and the median. There are a few exceptions, but most of the data is around the mean or median. Some things in the world that are normally distributed, grades, although teachers hope that students have more A's and B's, but sometimes grades resemble a bell curve with a lot of students getting a C. some students getting A's and B's, and some students getting D's and E's. Height or weight, most people are around the average, some people are higher than the average, and some people are lower than the average. And then student arrival times to class. Some students are late, some students are extremely early, but most of the students arrive exactly on time. The weights of mature Jersey cows are normally distributed with a mean weight of 950 pounds and a standard deviation of 45. So we start by drawing a diagram to represent the situation. Remember, my mean is exactly in the middle, 950 pounds. One standard deviation to the left would be 905, another to the left would be 860, and then a third to the left would be 815. And then I'll do the same thing for one standard deviation to the right, two standard deviations to the right, and three standard deviations to the right. All I do is add or subtract 45 each time. To find the z-score that corresponds to a weight of 1,000 pounds, I started with my equation, x minus x bar over s. I plugged in 1,000 for x and subtracted 950, the mean, and divided by 45, and I got 1.11. To find the weight in the 75th percentile means that I want to find a weight that has 75% of the data below it. What I did was, I went to my z-score table and I found a number that was very close to 0.75. I didn't find exactly 0.75, but I found 0.7517. To the left, I found that that corresponded with a z-score of 0.6, and then my hundredths place was 0.08. So my number is 0.68. I set that equal to my x minus x bar over s, and I'll solve for x, the weight. I started by multiplying both sides by 45, which canceled out this 45 in the denominator, and I was left with x minus 950 is equal to 30.6. I then added 950 to both sides, and I got x is equal to 980.6 pounds. Remember your units since it's a word problem. Part D is very similar to Part C. I want to find a weight that has 40% of the other weights below it. So I want to find on my z-score table a percent that's very close to 0.4. I didn't find exactly 0.40, but I did find 0.4013, which is very close to 0.4. That matched up with a z-score of negative 0.2 and 0.05, so my z-score is negative 0.25. So I set negative 0.25 equal to x minus 950 over 45. To solve, I first multiplied both sides by 45, and I got negative 11.25 equals x minus 950. After adding 950 to both sides, I get my answer, 938.75 pounds. For Part E, it's also helpful to draw a diagram. I want the percent of weights that are between 900 and 1,050 pounds. So what I'm going to do is find the percent that are less than 1,050 and subtract from it the percent that are less than 900. That'll take off this tail that I don't want. The first thing I did was find the z-score that corresponds to 900. I did 900 minus 950 divided by 45 and found I got negative 1.11. On my z-score table, I matched up negative 1.1 with the hundreds column, 0.01, and found the number 0.1335, or 13.35%. I'll do the same thing for 1,050 pounds. I got a z-score of positive 2.22, which corresponded to a percent of 98.64. Then to find the percent that are between those two weights, I will subtract 98.64 minus 13.35, and I'll got 85.29 Next, we want to find what weight has 10% of the weights below it. So if 10% of the weights below it will correspond to a z-score that goes with a percent of around 0.10. On my z-score table, I didn't find exactly 0.10, but I did find 0.1003, which is very close to 10%. The z-score that corresponds to that percent is negative 1.2, and then the hundredths column is 0.08. So my z-score is negative 1.28. I can set this equal to my z-score equation to solve for x. To solve, I multiplied by 45 on both sides, which will get rid of this 45 in the denominator. My equation has negative 57.6 equals x plus minus 950. I added 950 to both sides, and I got 892.4 pounds. Last one. What weight separates the middle 40%? Step 1, I'll start by drawing a diagram. My 950 is right in the middle. We want the weight that separates the middle 40%. If 40% is in the middle, then we have 60% left for the two tails. If I just want one of these tails, I'm looking at the z-score that corresponds to 30%. On my z-score table, there isn't a z-score that goes exactly with 30%, but I did find 0.3015, which is close to 30%. The z-score that goes with it is negative 0.5, and the hundredths column is 0.02. So I set negative 0.52 equal to x minus 950 over 45. When I solved for x, I multiplied by 45 on both sides to get rid of this 45 in the denominator. Then I added 950 to both sides, and I got 926.6 pounds. Now remember, since a bell-shaped curve is symmetrical, this z-score right here would be a positive 0.52, and so we could solve for that weight as well. I hope everyone does well in the quiz tomorrow. Make sure you email me if you have any questions.